Hello and welcome back to math class. Today we're going to be talking about decimal operation rules and the foldable for decimals. So we're going to specifically be talking about adding and subtracting decimals. Now, I want you to remember that decimals are a special kind of number. They are a rational number. And rational numbers are any number that can be represented in a ratio, and ratios look a lot like fractions, A over B, where B does not equal 0. B cannot equal 0 because we cannot divide by B. That would be undefined, and that's a bad thing until later, like end of high school, beginning of college later. Okay, so let's go on ahead and instead of using the fancy words of rational, we're just going to go on ahead and call it what we see, decimals, because I am talking specifically about numbers with a decimal point in them. And all numbers have a decimal point in them. So the first example that we are given is 7 plus 5.314. And I want to point out a couple things. One, I give graph paper for scratch paper. I'm working on graph paper, which reminds me, I changed the background color. Let me know if you prefer this. I remember in 6th grade, some of you really preferred this style of writing to the white background with black color ink. I guess it's easier on your eyes. Let me know in the comments. Let me know what we got. Anyway, graph paper is highly important. I'm a messy person. I tend to make a lot of math mistakes because I'm a messy person. Graph paper helps us line things up. And the number one rule of adding and subtracting rational numbers with decimal points is that the decimal points must line up. That's not going to work there. I'll put it down here. Okay, so this first number we've got is 7. Where's the decimal point on the 7? Well, it's invisible right now, but is that not the same thing as 7.0? It is. And I don't like this color because it's a little bit too dark. Let's brighten and liven things up a little bit with our Wednesday favorite. Okay, so we're going to line up our decimal point here. So we have a 7 point, and then I could go on ahead and write a 0 here. I'm probably going to write a couple zeros just looking at the way this math is going to go. And then I want to line up the second number, which is 5.314. So I'm going to line it up, 5.314. And this is an addition problem, so I can go on ahead and rewrite that. Oh, yeah, I forgot what color I was working on. Okay, now, what do I do over here? I've got nothing over here. Well, nothing. A good way to represent nothing is with a 0. And as long as I am to the right of this decimal point, I can add as many zeros out there as I want. So don't worry. Feel free, add them. It's part of invisible math. There are a lot of zeros out there. So now I'm adding. So let's go on ahead and let's get to it. That purple looks pretty. 0 plus 4 is 4. 0 plus 1 is 1. 0 plus 3 is 3. Very, very important. Decimal point, decimal point. Guess what goes right here? Decimal point. Okay? And if you have a hard time remembering that, put them in before you even start. Now I've got 7 plus 5, and 7 plus 5 is 12. So 7 plus 5.314 is 12.314. And that is our first example. Now look at another example would be our subtraction example. And they've given us the equation 15.6 or 15 and 6/10. Neatness matters. Minus 6 and 39 hundredths. Okay, so let's rewrite this vertically, and let's make sure we get our decimals to line up. So we've got 15, and we'll put our decimal point right here, and 6/10, and we're going to subtract. Now remember, my decimal point needs to line up. So I'm going to go on ahead and write my decimal point under here, and I've got my 6 just to the left, and then everything else goes to the outside. So it's really important to notice that I didn't just line everything up on the right-hand side. That's a no-go in this, okay? And let's go on ahead and we'll put our equation bar down here. But Mr. Holloway, there's nothing to subtract for the 9. And you're right. But remember, just like up here, we have endless zeros out here. So you can add the zeros to make things make sense. Now, at this point, it's just straight subtraction. 9 minus 0, can't do it. Have to steal from the tenths place. So we're going to put our 5 there. We're going to put our representative 10. 9 from 10 is 1. Okay. Let's change it up. 3 from 5. I'm going to take 3 away from 5. 5 minus 3, that would be 2. And now remember, I've got my decimals. Decimal, decimal, decimal. 6 from 5. That won't work. So I've got to steal from, ooh, that was bad choice of colors. Steal from my tens place. Add my 5. 6 minus 15, or I'm sorry, 15 minus 6, words matter, is 9. And then 0 minus 0 is, of course, 0. So my resulting answer is 9 and 21 hundredths. Remember, you always use the place value of that last digit, which is hundredths right there. So 9 and 21 hundredths. The key to remember is to be neat and make sure those decimals stay in a line. If you have a habit of writing off to the side like I do, make sure to use graph paper on this. And that's all there is to this. You should have a lot of good times and easy times with this. If you're having problems, hit me up in the comments. Let me know what you need to work on, and I'll maybe make a new video. Otherwise, like, subscribe, notification bell, and comments in the comment section. I'll see you in class.